Hello and welcome back. In this video, we are going to learn about the composition of functions. First, we learn about the definition of composition of functions, and then we'll solve some examples regarding composition of algebraic functions. So basically, when the range of one function becomes the domain of another function, or we can also say that when output of one function becomes input of another function, it is known as the composition of two functions, and the new function generated is known as the composite function. Like if we have two functions f of x and g of x, so if we replace the output of g of x in f of x, we call it f composition g, or simply it can be written as fg of x. It means that we are replacing the output of g of x as the input of function f of x. And similarly, there can be another composition g f of x, which means that we are replacing output of function f of x in the function g of x. And these two compositions are in general not equal. Most of the time they are not equal, but some specific values of x, they can be equal then. Now here is the example that we are given two functions f of x equals square of x plus 1 and g of x given as x plus 3, and first we are to find the composition fg of x. So fg of x means that we have to replace the output of g of x in function f. So we write it f of g of x. Then because f of x was the square of x plus 1, while now input is g of x, so x will be replaced with g of x, square will remain as it is, and plus 1. Now we replace g of x with its expression, which was x plus 3, so it will become the whole square of x plus 3, and plus 1 will remain as it is. Then we expanded the square of x plus 3 and added it to 1, so the composition fg of x equals x square plus 6x plus 10. Now let's talk about the second composition gf of x. What does it mean? That we have to replace the output of f of x as the input of g of x. That is why it is written as g of f of x. And now what was the function g of x? It was x plus 3. When the input of function g of x was x, the output was x plus 3. Now input of the function g is f of x, so x will be replaced by f of x, then plus 3 is kept as it is. And then we replaced the value of f of x, which was given above, x square plus 1, and then added it, and we get g f of x equals the square of x plus 4. And we can see that these two compositions have different values. They are not equal, but they can be equal at certain values of x. Now let's discuss this question where the function f of x is given as 2x plus 1, while function g of x is given as x square plus x square minus 2. And he asked to find the fg of 2. Here we do not need to find the composition of the functions and then we replace the value. No, we can just do it directly by writing it f of g of 2. So we can find g of 2 easily by replacing 2 in function g of x. The function g of x was the square of x minus 2, so we keep f as it is and write the value of g of 2. It will become the square of 2 minus 2. Now we have to simplify this value. The square of 2 was 4 and 2 is being subtracted from it, so it will become 2 again. And f of 2 means that we have to replace x of f of x with 2. It will become 2 times 2 plus 1, giving us the value of fg of 2 equals 5. Okay, let's discuss the second one where he said g f of 3. So g f of 3 mean that we have to find g of f of 3. So first we find f of 3 and then we replace it over here. Keep the g as it is what will be the value of f of 3? We have to replace x of f of x with 3. So it will become 2 times 3 plus 1. Let's simplify it. It will be g of 2 times 3, 6 plus 1 is 7. So now we need the value of g of 7. G of 7 means we have to replace the x of g of x with 7. So it will become the square of 7 minus 2, and we can see that that will be the g of 3 equals 49 minus 2. We can write directly it as 47. So these are the two compositions, two specific values of the composition f g of 2 and g f of 3. Now we have the general compositions below, like we have to find f g of x, and then we have to find g f of x in part C and D. So in part C, I can write it as f of g of x. Now we can see the function outside, it is f of x. So what was the value of f of x? It was 2x plus 1. Now we have to replace x with g of x. So it will become 2 times g of x plus 1. Now we have to replace the expression of g of x here. G of x equals square of x minus 2. So we replace it over here. X square minus 2 plus 1. Now expand it and it will become 2x square minus 4 and then plus 1, and the result will be the square 2 times the square of x minus 3. So that is the value of general composition fg of x. Similarly, let's find the second composition g f of x, and we know it will become g of f of x. Now the function outside, it is g, so we will replace x of g by f of x. G of x was given as the square of x minus 2. So now we have to replace this x with the f of x, because now input is f of x. So it will become f of x and put a square over it, then subtract 2 from it. Now we have to replace the value of f of x over here, because f of x have an expression in it. It was 2x plus 1. So it will become 2x plus 1 its whole square minus 2. Now we have to find the value of whole square first. It will become 4x square plus 4x plus 1 minus 2, and the final answer will become 4 times x square plus 4x minus 1. So that is the composition g f of x. G f of x, and we can see that the two compositions once again have different values. Now these are the two general compositions we discussed, but the two other compositions we also discuss sometimes, like we have f of x, or it can also be written as f square of x. So what does the value of f of x will become? It will be f of x. So basically it means that we have to replace the x of function f of x with itself. Like f of x was given 2x plus 1. So we have to replace this function x with, again, the expression of f of x, or simply f of x. So I will write it as 2 times x is replaced by now f of x, and plus 1 is as it is. All right, then we replace the value of f of x, and f of x was 2x plus 1, and plus 1 outside is kept as it is. Now we have to expand it. It will become 4x plus 2 plus 1, giving us 4x plus 3. So that is the composition f of x. Similarly, the second composition g of x will also exist. In the same manner, it will be written as g of x. Now, what does it mean? That we have to replace the x of function g with itself g of x. And what was the function g of x? We can see it was x square minus 2. We have to replace this x with the input g of x. So I will write it as g of x square, because initially it was x square. X is replaced with the input g of x, minus 2 is kept as it is. Once again we have to replace the value of g of x, and g of x was x square minus 2, and there is a whole square above it. Minus 2 is kept as it is outside. So now we have to simplify it, and now we know that the whole square of this value will become x raised to the power 4, then minus 4x raised to the power 2, and plus 4, and minus 2 is already there. We can just simplify it to get the final answer of the composition g of x, or g square of x. It will become x to the power 4 minus 4x to the power 2 plus 2. That is the final value of self composition g of x, and the first self composition f of x was 4x plus 3. So that is how we work with the composition of algebraic functions, and we can also find some values from these compositions. Now I have given a self assessment. Pause this video for a minute, try this question, and you can see the answer below over here.